Yeah, back when those were the common tests, it didn't seem like that they were very good at placing a lot of students.
Yeah, I can see that too.
Yeah. But I don't know, it's just sort of part of the territory. You get students who should be in the previous class instead of the class we're in.
Well, we started out with a pretty decent people classroom, and now it's me and that lady most of the time.
Yeah.
Hi there. Hi there.
We'll start in about 1 minute. We'll be in section 9.5 today and on Monday. This is the section on problem solving with quadratic equations. Well, we've seen the problem solving strategy before. We'll review that real quick. Read the problem. Sometimes you need to read it more than once, and that's okay. If it takes 4 or 5 times before you understand it, then do what it takes. So understand the words and the ideas. Identify what needs to be found. Step 3, pick a variable to represent each quantity that needs to be found. And then in step 4, use the variables in the given information to formulate an equation, sometimes more than one equation. Eventually, though, you want a single equation to solve, and then solve it using the algebraic properties. And then you can, there's always a way to check the answer to verify that the answer makes sense. Okay, here's our first problem. The product of 2 consecutive positive odd integers is 143. Find the integers. It wouldn't be too hard to find those integers just by trial and error. But hopefully you'll go through the process of learning how to pick variables and set up an equation and then solve the equation. That's really the purpose of these types of problems. So find the integers. The integers are 2 consecutive positive odd integers. One pair of consecutive odd integers differs by 2. For example, 3 and 5 are consecutive odd integers, and 3 is 2 less than 5. So in general, if we have 2 consecutive odd integers, we can represent them by x and x plus 2. Then it says the product of those consecutive positive odd integers is 143. And so that means the equation that we want, the product means to multiply x times x plus 2. And that product is 143. The resulting equation is a quadratic equation. When we multiply x times x plus 2, we get x to the second plus 2x equals 143. And then we can solve this quadratic equation using any method that we want. So what method do you want to use?
Quadratic formula? Quadratic formula?
Okay, we can use the quadratic formula. So we subtract 143 from both sides. And we get x squared plus 2x minus 143 equals 0. If we use the quadratic formula, the value of a is 1, b is 2, and c is negative 143. Okay, up here I'll write the quadratic formula, x equals negative b plus and minus the square root of b to the second minus 4ac, all divided by 2 times a. Okay, so here we get x equals negative 2 plus and minus the square root of 2 to the second minus 4 times 1 times negative 143, all divided by 2 times 1. Okay, then x equals negative 2 plus and minus the square root of a number. We have 2 squared, which is 4, and we're subtracting 4 times 1 times negative 143. So that's going to be, since we're subtracting a negative, it's going to be plus a positive. And 4 times 143 is 572. So 4 plus 572, all divided by 2. And then the square root of 576. Let's see, that's just 576 is a perfect square. The square root of 576 is 24. So this equation has 2 solutions, x equals negative 2 plus and minus 24, all divided by 2. But in this problem, we just want the positive consecutive integers. So for our purposes, we'll just pick the positive solution, which is negative 2 plus 24 divided by 2, or 22 divided by 2, which is positive 11. Okay, so our integers, our consecutive positive odd integers are 11 and 11 plus 2, which is 13. It's pretty easy to verify that 11 and 13 are the integers that we want. We see that they are both positive, they're both odd integers, they are consecutive odd integers, and the product, 11 times 13, is 143. Okay, so as I mentioned earlier, it would have been easy just to look around until we found 11 and 13. But there is I guess, a higher purpose for learning how to set up an equation using variables. Hey, the next problem, the area of a triangle is 136 square feet. The base is 2 feet longer than 4 times its height. Find the base and height of the triangle. Well, tell me what we need. What do we need to know before we can set up an equation? Besides picking variables to represent the quantities that we are supposed to find, what else do we need? The hint is in the first sentence. The first half of the first sentence, the area of a triangle. So that means we need to know the formula for the area of a triangle. Formula for the area of any triangle. Do you remember what that is?
Length times height.
What is it?
Length times height.
Length times height could be a parallelogram or a rectangle, but for a triangle,
A squared plus B squared.
that is the Pythagorean theorem for a right triangle. But for the area of a triangle, so I'll draw a parallelogram. So a parallelogram has 4 sides, and opposite sides are parallel. A rectangle is a special case of a parallelogram. But every parallelogram has a height and a base. So we could say this is the height and this is the base. So H for height and B for base. And the area of a parallelogram is base times height. Area equals base times height. Well, if you have a parallelogram, you can construct 2 triangles that have the same area. So one way to construct a pair of triangles that have the same area is to divide those 2 triangles. Those 2 triangles have the same area. A second way to do it would be to divide the parallelogram this way, so that those 2 triangles have the same area. Well, if the area of the entire parallelogram is base times height, then we can use that to help us find the area of a triangle. One half base times height. Area is 1/2 base times height. Okay, so this is the formula that we need for this problem. We're given information about the area. The area is given to be 136 square feet. And we are also told what the relationship is between the base and the height. Okay, so our given information, if we're going to use this formula, A is 136 square feet. And then in the second sentence, it says the base is 2 feet longer than 4 times its height. So my strategy is generally, since the base is described in terms of the height, I'll pick a variable to represent the height. You can pick any variable that you want. I'm going to pick x feet for the height. And then I'm going to use the second sentence that describes the base in terms of the height to come up with an expression for the base. It says the base is 2 feet longer than 4 times the height. Since the height is x feet, 4 times the height is 4x, and the base is 2 feet longer than 4x. So the base is 4x plus 2 feet. Okay, do you see how that works? And then we just use the area of a triangle formula, and we put in the numbers and the variable expressions. So in this formula, replace capital A with 136, and that's equal to 1/2 times the base. The base is 4x plus 2, and then times the height, which is x. The resulting equation is just a quadratic equation. Notice we can multiply 1/2 times the quantity 4x plus 2. That's one option. So we get 136 equals the quantity 2x plus 1 times x. And then 136 equals 2x to the second plus x. And then if we write the quadratic equation in standard form, we can write it as 2x to the second plus x minus 136 equals 0. We know how to solve any quadratic equation. We can always use the quadratic formula. Okay, so if we use the quadratic formula, we have A is 2, B is 1, and C is negative 136. Okay, so let's use the quadratic formula. X equals negative B, so that's x equals negative 1 plus and minus the square root of 1 to the second minus 4 times 2 times negative 136, all divided by 2 times 2. Okay, then we do the arithmetic. -1 plus and minus the square root of a positive number divided by 4. So inside the square root, we have 1 minus 4 times 2 times -136. So it's when we subtract a negative, that's the same as adding a positive. And 4 times 2 times 136 is 800 plus 240, 1040 plus 48. So I get 1088. So you might want to check my arithmetic on that. And then inside the square root, we have the square root of 1089. Oh, I think that's right. What's the square root of 1089? Not a whole number? Okay, 33. So -1. Notice we don't want the negative solution. The -1 minus 33 is negative. We want the positive solution. So x equals -1 plus 33 over 4, or 32 over 4, or 8. All right, so the height is 8 feet, and the base, 4 times 8 plus 2, is 34 feet. And we can verify, well, it's pretty clear that 34 is 4 times 8 plus 2. So the base is 2 more than 4 times the height. And then 1/2, 8 times 34 is 4 times 34. 4 times 30 is 120. And plus 4 times 4, 120 plus 16 is 136. Okay, so that checks out. Okay, let's move on to the next problem. Working together, Bertram and Florence can clean their shop in 2 hours. When each works alone, Florence takes 3 hours longer than Bertram. Find how long it takes each to clean the shop alone. Hey, this is a work problem, so equations have the form rate times time equals 1. So rate times time equals 1. 1 represents the task or job that they're doing. Okay, so when they work together, Bertram and Florence can clean the shop in 2 hours. So we can write the rate times time equals one equation for when they work together. Bertram works at a certain rate. Florence works at a certain rate. And in 2 hours, they can clean the shop. So notice that when they work together, we add the Bertram's rate and Florence's rate and multiply that quantity by the amount of time to clean one shop. Okay, we're told that when each of them works alone, Florence takes 3 hours longer than Bertram. So we pick a variable to represent the amount of time it takes Bertram. So Bertram works at a certain rate. And in X hours, Bertram can clean the shop. So Bertram's time is X hours. And then an equation for Florence. So Florence works at a certain rate. Florence takes 3 hours longer than Bertram. So if Bertram takes X hours, the amount of time Florence takes is X plus 3 hours. So in other words, Florence's time is X plus 3 hours. We want to know what X and X plus 3 are. So we need an equation whose only variable is X. So we've done this sort of thing before. Solve for each of the rates. Bertram's rate plus Florence's rate is 1/2. So more technically, when Bertram and Florence work together, they can clean 1/2 of the shop per hour. This is their hourly rate. When Bertram works by himself, his rate for the moment is 1/X. And Florence's rate is 1/X plus 3. In the next step, we'll get our equation whose only variable is X, replace Bertram's rate with 1/X, add that to Florence's rate, which is 1/X plus 3, and the sum of the two rates is 1/2. Well, we've seen how to solve equations like this before. The restricted values are X equals 0 and X equals -3. The least common denominator is 2 times X times the quantity X plus 3. So we multiply every term on both sides by 2X times X plus 3. When we multiply 2X times X plus 3 by 1/X, the X's cancel, so we get 2 times X plus 3. When we multiply 1/X plus 3 times 2 times X times the binomial X plus 3, the X plus 3 factors cancel, so we're just left with plus 2X. And on the right-hand side, multiply 1/2 times 2 times X plus 3. The 2's cancel. We're left with X times X plus 3. What we have is a quadratic equation. So we'll apply the distributive property of multiplication over addition twice, combine like terms and set one side equal to 0. And then at the very least, we can use the quadratic formula. So on the left-hand side, 2 times x plus 3 is 2x plus 6 plus 2x. On the right-hand side, x times x plus 3 is x squared plus 3x. So we'll make the left-hand side 0. We'll subtract a total of 4x from both sides and subtract 6 from both sides. So we get 0 equals x squared minus x minus 3. If we use the quadratic formula, let's do that in this space. So a is 1, b is -1, c is -3. So x equals the negative of -1 plus and minus the square root of the number -1 squared minus 4 times 1 times -3, all divided by 2 times 1. And then we get x equals 1 plus and minus the square root of 1 minus -12, which is 1 plus 12, or 13, all divided by 2. The solution we get from subtracting is negative, so we want the positive solution. So x equals 1 plus the square root of 13 over 2. So that's how many hours it takes Bertram by himself. So this is a little bit less than 1 hour because the square root of 13 is a little bit, whoops. Sorry, it's a little bit more than 2 hours, but less than 3 hours. You can use a calculator to get a decimal approximation if you want. So Bertram takes 1 plus the square root of 13 over 2 hours, and Florence just add 3 to that. So when we add 3, that's 6 over 2. So we would get 7 plus the square root of 13 over 2 for Florence. So the question is, shouldn't it be plus x? No, because we subtracted a total of 4x. 3x minus 4x is -1x. Okay, let's move on to the next problem, number 4. In a total of 5 hours, an airplane flies 300 miles with the wind and 300 miles against the wind. With no wind, the airplane flies at 125 miles per hour. Find the speed of the wind. I'll give you 2 or 3 minutes to to work on this one. So see what you can get accomplished in 2 or 3 minutes. Well, I'm going to interrupt you. I do see a mistake that I made on the previous problem. So it wasn't the minus x part, but I should have subtracted 6 instead of subtracting 3. So let's do that real quick. If we combine like terms on the left-hand side, 4x plus 6 is x squared plus 3x. And then subtract 4x from both sides and subtract 6 from both sides, we get x squared minus x minus 6. We can solve this one by factoring. The two factors are x minus 3 and x plus 2. And the only solution that makes sense is the positive one. So x equals 3, that's Bertram's time. So 3 hours for Bertram. And x plus 3 is 6 hours for Florence. Okay, let's go to this problem. In a total of 5 hours, an airplane flies 300 miles with the wind and 300 miles against the wind. If there is no wind, the airplane flies at 125 miles per hour. Find the speed of the wind. Okay, so pick a variable for the wind speed. So I'll pick x miles per hour for the wind speed. And then there are two scenarios described. The airplane flies with the wind, and then it flies against the wind. So with the wind, the airplane will be traveling at 125 plus x miles per hour. If there was no wind, it would be 125 miles per hour. But since it's going with the wind, it's x miles per hour faster. And we'll use T sub W for the amount of time it takes to fly 300 miles with the wind. Okay, so we have rate times time equals distance. When the airplane flies against the wind, or into the wind, the plane will be traveling at 125 minus x miles per hour. And we'll use T sub A to represent the amount of time it takes to fly the distance of 300 miles against the wind. Okay, we want to know what the wind speed is. We want to know what x is. That means we need an equation whose only variable is x. So how do we get there? A clue is in the first part of the first sentence. In a total of 5 hours, the airplane flies 300 miles with the wind and 300 miles against the wind. Of course, it's going to take more time to fly 300 miles against the wind than with the wind. But we're just told that the total amount of time is 5 hours. So that means the time it took to fly 300 miles with the wind plus the amount of time it took to fly 300 miles against the wind is 5 hours. So to get our equation whose only variable is x, we'll do a familiar thing. What are we going to do? It's the same sort of thing we've done a few times this semester. So this equation, with the wind equation, we're going to solve for T sub W. So divide both sides by 125 plus x. So T sub W, that represents the amount of time it takes to fly 300 miles with the wind. So T sub W is 300 divided by 125 plus x. And then solve the other equation for T sub A. T sub A is the amount of time it took to fly 300 miles against the wind. So T sub A is 300 divided by 125 minus x. Okay, then in this equation, we replace T sub W with 300 over 125 plus x. We're adding that to T sub A, but T sub A is 300 over 125 minus x. And those add up to 5. Okay, we know how to solve this kind of equation. The numbers might seem a little big, but with a high-powered calculator, it's not too bad. The least common denominator is 125 plus x times 125 minus x. So we multiply every term on both sides of this equation by the least common denominator. When we multiply the left-hand side, 300, first we multiply this first term on the left, 300 over 125 plus x times 125 plus x times 125 minus x. The 125 plus x factors cancel, so we're left with 300 times 125 minus x. Then multiply the next term, 300 over 125 minus x, by 125 plus x times 125 minus x. This time the 125 minus x factors cancel, so we get plus 300 times 125 plus x. And then on the right-hand side, multiply 5 times the least common denominator, and it's 5 times 125 plus x times 125 minus x. Hey, I'll show you some maneuvers that you can use that help if you don't always want to depend on a calculator. Notice that 5 is a factor of 300 for 2 of those summands, and 5 is a factor on the right-hand side. So if we divide every term on both sides by 5, we'll get 60 times 125 minus x plus 60 times 125 plus x. And that's equal to 125 plus x times 125 minus x. Okay, then what we can do, write 60 times 125 minus x, but leave the 60 times 125 as a product, and then minus 60x, and then plus 60 times 125 plus 60x. On the right-hand side, we're multiplying a binomial and the conjugate of the binomial. So if we were to multiply it out, the minus 125x and the plus 125x add up to 0. So we're just going to get 125 squared minus x squared. Okay, on the left-hand side, the minus 60x and the plus 60x, those add up to 0. So let's do one more thing to the left-hand side. I have 60 times 125 plus 60 times 125. So that's the same as 2 times 60 times 125. So I'm going to write it as 120 times 125 equals 125 squared minus x squared. And then in the next step, I'm going to add x squared to both sides and subtract 125 squared from both sides. So we'll get x squared and then plus 120 times 125 and minus 125 squared equals 0. Okay, then we get x squared. Out of these two terms, the 120 times 125 and minus 125 squared, I'm going to factor 125 out. So I'll write x squared plus 125 times 120 minus 125 equals 0. 120 minus 125 is negative 5. And so plus 125 times negative 5 is x squared minus 625 equals 0. And then that means x squared equals 625. 625 is a perfect square. And we want the positive solution. So if x squared is 625, x equals 25. The positive 25 is the solution that we want for this one. So 25 is the wind speed, 25 miles per hour. All right, we're about out of time. On Monday, we'll work on the rest of the problems. You can work on those ahead of time if you want. But that's all for today. So go ahead and sign in for attendance.
Have a good weekend.
You too.